So gents, some of you are out on a well-being day, which means you're going to miss my theory lesson. I think we're going to miss the electronics lesson for those electronics boys, because you should already have quite a good knowledge in that area. The electronics section in the CGP can be found on pages 24 to 27 of your textbook. So get your textbook out and have a look at that. Right, let's go. Electronic symbols, can you identify them? So which is each symbol? Use my pointer. What's this? This is probably the one that's going to fox you the most. This is a pressure pad. Okay, the pressure switch. We've got this, which can also be drawn with a circle. It's an LDR, and I'm sure you know the LED. This one, this is an AND gate. If both of its inputs go high and its output goes high. We've got a PTM, we've got a thermistor, you might not know that one. We've got a speaker, we've got a bulb or a lamp, you can also call it. Push to break, single pole, single throw, and we've got a buzzer, and we've got an OR. For those of you that don't know what they do, this pressure switch is pretty obvious. LDR, I think you all know. LED, you'll know. AND gate is makes a decision. So it's a logic gate. This is just a normal press switch, which you press and then you take your finger off it, it goes off. Thermistor, well, that detects changes in heat. Speaker, plays sound. Bulb emits light. And you've got push to break, so it's always on until you push it and then it breaks. Single pole, single throw. It's like a rocker switch, like a slide switch. You turn it on or off. You've got the buzzer, which makes a noise. But you can't play different tones, I think, through it. And you've got the OR gate, which we'll go into a little bit later. What I would do is I would spend 5 minutes drawing them on some flashcards and then putting the names of them on the back. You can probably draw, as you actually, I'd draw this set here on one flashcard because these are all inputs, and then I would draw this here, or these 6 here, on another flashcard, as they are outputs and logic gates. Alright, so picture on the front and then what they are on the back. Okay, you can pause this, and once you've done it, you can play it some more. Right, let's go on. Electronic circuits. Circuits are electronic components connected together with a power source. What metal is used to conduct electricity? So what metal is used inside here? What do you reckon it is? Copper. What are the physical and working properties of these electronic cables? What do you reckon then? So we've got the copper, and then we've obviously got the plastic coating. Copper, well, it's going to obviously be electrically conductive, isn't it? It's going to be probably thermally conductive as well. How do they make it? Well, it's going to be ductile, and it bends pretty easily, doesn't it? So it's going to be malleable. We've got the plastic surround. Is that going to be a good electrical conductor? Probably not. Is it going to be a good thermal conductor? Probably not. So that's 2 things that you could say is going to be a good insulator in both of those. Is it going to be chemically resistant? Most plastics are. Is it going to be water resistant? Probably. Okay. Electronics, PCB, more complex circuits are constructed on a printed circuit board, PCB. These have thin copper tracks opposed to wires that are laminated to a layer of fiberglass. So what you can see here is the fiberglass. If we span it over, you would see the copper. That's been, of course, adhered to it in some way. So that's a lamination. On top of that would go your photoresist. On top of that would go the that sort of sticker, that opaque sticker that you peel off, which is sometimes blue or black. Voltage from a power source pushes the electronic current around the circuit. What are these components? You can recognize those are resistors. What unit are they measured in? What is the resistance measured in, I should say? That's going to be ohms. What are the resistors used for? Well, they're used to slow down, or slow down, I suppose, the movement of electrons. And so you can protect components, or you can sort of direct current, so reducing current and therefore protecting components from damage, or directing current to particular parts of the circuit. Electronics inputs, processors and outputs. Can you identify inputs and outputs on a mobile phone? And which one of these is both? Is something else? So we've got status bar, of course, that is an output. Application icon, again, is an output because we can see it's interacting with the outside world. It's a stimulus. Touch screen, we have to touch that to get it to work, so it's an input. Headphone port is going to be an output because it's emitting small amounts of electricity, which is converted into sound. Dot connector, that's probably the charger, isn't it? That's probably an input and an output, to be honest with you. Home button, that's going to be an input. Internal speaker, well, the speaker is going to be an output. Volume button, that's going to be an input, isn't it? The sleep wake button, it's going to be an input. Wi-Fi antenna, that's going to probably be both, isn't it? Both in input and output. It's going to be receiving and emitting signals. Electronics inputs. Inputs are triggered by external stimuli such as pressure, temperature, or light. Often they are referred to as a sensor because they convert a specific type of energy, for example, light into electrical energy, which is used to control a circuit. Can you remember what these inputs are used for? What's this one? This is the difficult one. This is the pressure switch. That's what it looks like. Just a big sort of black rectangle. This one is just the PTM or the PTB, push to brake, push to make. Well, you can see it's not made at the moment. The circuit isn't made, so you've got to push it to make the circuit. So it's a push to make, and that's what it looks like. And a push to brake. They don't look any different, to be honest with you. Sometimes the push to makes are red, push to brakes are black, but not exclusively. This one also comes in a circle. It's the LDR. The other symbol looks a lot more like the top of that, to be honest with you. It's got a circle with a funny wiggly line through it. Got this one, which is a thermistor. And finally, we've got a single pole, single throw. Now these come in rocker switches like this, or slide switches like that, or I think there's other ones as well, other types of switch, which you flick it to make a connection, and you flick it the other way to break it. Electronics function of the input through the thermistor. These components detect a change in temperature. In hotter conditions, the resistance falls. So that's important. In hotter temperatures, in hotter conditions, the resistance falls. That could be a question, a one marker. Where they're used, where they're going to be used, central heating. Yeah, they're going to be used in your washing machine. Anything that gets hot is going to have a thermistor in it to stop it overheating. LDR, these components detect the change in light. In brighter conditions, again, this is important, in brighter conditions, the resistance falls. So, where they're going to be used, street lamps are the obvious example here. So as it gets light, the lamp goes off. Pressure sensor, these components detect change in pressure. This change creates a rise or fall in resistance. Okay, and it's that resistance which is detected by other components within the circuit. What they're used for? Scales. You know, when you've got electronic scales and you put something on it, it's going to convert that weight into a resistance, and then that resistance is going to be converted into a number that we can understand. Okay, electronics outputs. Outputs use the electrical energy to create a stimulus such as light, heat, or sound. Can you remember what these ones are called? We've got the LED. It's a diode, by the way, so electricity can only pass one way through it. Yeah, that's fundamentally what it is, an electronic diode, light emitting diode. So we've got the energy moving in the direction of the triangle, but as it moves through, it gives off light. So that's number one. Number two, that's a buzzer. Yeah, that just gives off one type of sound. A speaker can give off a whole variety of sounds that we can understand as words. And then we've got a bulb or a lamp, which I'm sure you recognize, quite old these days though. Okay, electronics function of the output. Speakers and buzzers use vibration to create sound from electrical energy. Speakers are used in TVs and phones. Buzzers are used in many household appliances such as washing machines and microwaves. LEDs and lamps create light from electrical energy. LEDs are used in electrical products, from your phone torch to flashing lights on your router at home. You know what you get your Wi-Fi from. That's always flashing away, isn't it? That's an LED that's flashing. Lamps have largely been replaced by more efficient LEDs. They used to be used to illuminate rooms in your house or in your car headlights. Right, electronics, the process, the bit in between. So electronics kids are going to be familiar with these. These aren't the microcontrollers. These are the static components. These are the components that they come in one way and they stay in that way. You can't program them in any way at all. So integrated circuits, or ICs, consist of millions of resistors, transistors, and capacitors. ICs are pre-made components and make electronics products much smaller. That's what's called miniaturization, and cheaper to manufacture. Of course, they're cheaper because they're smaller, and they make products cheaper because you don't have to make them so big. The circuit boards aren't so big. They're not going to spend a long time actually making the thing. There's a whole variety of reasons why miniaturization and the impact that's had on the cost of electronics in the modern world. ICs cannot be programmed and therefore only function in one specific way. However, the manner in which they're connected to a circuit can make them more versatile. Okay, so certain legs are going to be the inputs, certain legs are going to be the outputs, certain legs are going to have to go high or low, other legs are going to have to do things like the reset or the enable to make it work properly. If you want to, you can watch this. This is a little clip just showing how microchips are made. It's quite interesting. Let's move on. Microcontrollers. Microcontrollers, MCs, are a special type of IC that can be programmed and then reprogrammed. They have memory, a processor, and at least one output and at least one input, but often many more. They are tiny computers. They've got the inputs, got the outputs, got memory. They're effectively a computer. MCs do the job of many ICs, however, are considerably more expensive. When I say considerably more expensive, these cost about £1.50 for a 4017. Okay. And if we're looking at this sort of thing, an Arduino, well, Arduino I think it's about 15 quid. But if I went for a similar size microcontroller to this one here, it would be about £3.50. So they're about 3 times the price. I hope that makes sense. The MCs can be programmed to react when one of its input pins goes high or low. It will control other components by sending one or more of its output pins high or low. And that's all it does, really. And it's that wired up correctly which communicates with you specific things. Like, for example, it may be numbers on a 7-segment display, it may be sound, or even tunes playing. Electronics, ICs and MCs, both integrated circuits and microcontrollers can be used to make decisions and create timing circuits and counters. However, only microcontrollers can be reprogrammed, that's really important, reprogrammed to alter how the inputs and outputs react. So what we've got here, we've got electronics programming a timing function. A timing function is often used as a delay in a program, like a pause, just wait. It pauses the program for a specific amount of time before continuing. Can you explain how this program controls a circuit? So what we've got here, we've got, not anymore, we've got a circuit here. This circuit is a microcontroller. It's got its inputs on the left, it's got its outputs on the right. Its output is an LED, its input is one of those push-to-make switches. Don't worry too much about this resistor. It's what's called a pull-down resistor. It's getting a high here, and it's getting a low here. Okay, so that's working. So what does this circuit do then? Sorry, not this circuit. What does this program do? Start. Is G1 on? No, this is G1. Is it on? Well, if it is on, if you're pressing that down, because then the electricity is going through and making G1 high, then this is going to happen. If it isn't, then that's going to happen. So let's just start with it. If it isn't, G4 is going to go low. So if G4 is low, then that means that that LED is going to be, it's not going to go on. Okay, sorry about that. Just had a conversation with Mr. Roberts about some of the bits and pieces. So what have we got? We've explained the circuit, and now we're going on to the programming. So the programming starts with the start, and surprisingly, it's asking the question, is G1 high or low? So we went through, if the push to make is on, G1 will be high, and therefore we go this way. If it's not on, it will go around this way. So if it is not on, G4 will be low, the LED will be low. Right, that means that if we press that button down, G1 will go high, G1 is high. If G1 is high, then G4 will go high, which means the LED will turn on. It's going to turn on, and then we've got a wait command in here. It's going to wait for 3 seconds. So it's going to be on for 3 seconds, and then it's going to go round again. Now when it goes round again, it's going to see that G1 is likely off because we've pressed the button and then we've released it. So if it's off, then it'll turn G4 off. So the LED will go on for 3 seconds, and then given that the person is no longer pressing the switch, will then turn off. All right, that was a mouthful. Okay, so that's that. So have a look at this, programming and counting functions. A counting function will often record how many times an output pin has gone high and then low. This could be a button being pressed or the revolutions of a wheel. This is often converted into an output. Can you explain how this program, can you explain how this program controls the circuit? Right, let's have a look at this little circuit here. So again, we've got this microcontroller, we've got a high, we've got a low, we've got an output here on an LED, and we've got 2 different inputs. So very similar to last time, but just a little bit different, got an extra input. So let's have a look at this program. This is interesting because we're actually using a variable here. And of course, a variable is a letter or a symbol, I think, that you can attribute 1 or more different values to. So we start by saying f equals 0. All right, so f equals 0. Is G1 on? Well, what is G1? G1 is this one, so is that one on? If that one is on, what happens? Well, this happens, okay? And if that isn't on, what happens? Well, we're going to ask the question, is G3 on? Now, G3 is this one. Okay, so if neither one is on, then what happens is we just go back again. We just do this loop around and around and around. And what it's looking for, this circuit, is it's looking for G1 to be on. It's looking for this one to be on. So if we press this one, we increase F by 1. That's what this does. Okay, and then it's asking, is G1 off? That just means you've taken your finger off the button. So the idea behind that is it doesn't just keep on increasing F with your finger on the button. You've got to put your finger on the button, take it off, put your finger on, take it off, put your finger on, take it off to increase it 3 times. So G1 on, increase F by 1. So F, every time it goes through this loop, is going to go up by 1. So it starts on 0. If we went through this loop once, it would go up by 1 time, twice, 3 times, 4 times, depending upon how many times you press G1. So if you press G1 4 times, F will equal 4. Let's go over to G3. G3 is what's called a loop. Now a loop will loop for a set number of times. Now for this it's 1 to F. Can you see that 1 to F? So it's 1 to, we said F will equal 4. So this is going to loop 4 times. And when it does loop, what's going to happen? Well, what's going to happen is G4 is going to go high, so the LED is going to go high, then it's going to go low. So for the loop, which is going to be 4 times in this instance, the LED is going to flash 4 times. Let's have a look. So press it 7 times, and then it flashes 7 times. This is more complex than you need to know, but those kids that have done electronics and those kids that are doing computer science, I think will probably understand. And you may well get something about a timing function or a loop or a variable. So I hope that has cleared up what those things are on a basic level. Electronics ICs and decision makers. Certain ICs described as logic gates. We looked at these right at the beginning. We had an and, or, and. That was it actually, an or, an or. Are described as logic gates and can make decisions depending if their input legs are high or low. Microcontrollers can do exactly the same thing. That's part of their program. Below is a chip showing how an and, or, and not logic gates work. Right, just before we go into this, The actual component does not look like this, okay? Or like that, or like that. The component looks more like this, okay? So what you usually get is a high and a low, and what you usually get is like 4 different gates within your chip. And your chip may be a 14, maybe a 16 pin, what they call dual in line. That means there's 2 lines, dual in line. A SIL is a single in line. It'll be a dual inline chip, okay? So when we look at this, we've got an AND gate, which has got 2 inputs and an output. We've got this OR gate, 2 inputs and an output, and then we've got this one. This one's a bit odd because presently we have this push to make is not down, and yet it's still illuminating the LED. And that is because in actual fact it has another leg. It's just not represented on this diagram, okay? So let's see how these work.
This circuit shows you logic gates of decision makers. We have the AND gate, we have the OR gate, and we have the NOT gate. We also have the high circuit on the left-hand side and the lower.
So it's the high of the circuit, it's the lower of the circuit. We've got AND, we've got OR, and we've got a NOT. 5 different LEDs. Sorry, 5 different push-to-make switches, 3 different LEDs. I don't think you can hear the audio. So this is the AND gate, and this is the PTM. And if I press that one down, pressing Shift to make that stay down, and then I press the other one, you can see that that LED goes on. And that's because both the inputs to the AND gate are high, but if I let one of those push-to-makes off, you can see that the LED turns off. And so moving on to the OR gate, if we press one down or the other one down, you can see the LED goes high, or pressing Shift again, with both, we press them both down, then the LED will go high. So this is a bit different. If one or the other or both are high, then the OR gate will have an output. And so now we've got this, which is a NOT gate, or also known as an inverter. So if we press this down and complete the circuit, push to make down, the LED turns off. If we release it, the LED turns on. So with a high input, there is a low output, and with a low input, there is a high output on the gate. All right? I hope that made sense, and I hope you couldn't hear the original audio, or it's going to be a right muddle. All right, so what do we got? Electronics programming. Can you write a program for a bike light that when the button is pressed, a LED starts flashing once a second? If the same button is pressed, held down for a second, the LED stops flashing. So what are we going to do? Well, we're always going to start with the start, aren't we? This is the start command, and then we're going to ask the question is, well, it's going to be this one, isn't it? G1, is G1 on? And if G1 is on, then we're going to start the flashing, which would be a high and low, wouldn't it? Okay. And that would be flashing once a second. So we'd have to have a little wait command in between those, high for half a second, for example, low for half a second. And then if the PTM is not pressed again, it keeps on doing that. It keeps on going round and round and round in a loop. However, if that is pressed again, then what's going to happen is it's going to stop. So let's have a look at how that looks. So we've got the start here. I can play this, I think. So we've got G1 going on, just looping round. You can see that the PTM's been pressed, and it's now flashing away, going through that circuit. And if we press it again, that diamond, this one on the bottom here, is going to turn it off. So we've got the first one, which turns it on, and then it enters a loop, flashing away, and then if you press it again, it turns it off and goes back. The reason the wait command is in there is because if you press that, it moves so fast, it will start up the circuit again, or start up the program again. So the wait command just gives you enough time to take your finger off the button. All right, finally, what do we got? Come on, pressure switch. We got the LDR, LED, got the AND gate we just looked at, PTM, thermistor. We've got the speaker, we've got the bulb, we've got the push to brake, we've got single pole, single throw, we've got the buzzer, and we've got the OR gate. All right, I hope that's been of some help, and make some notes on this. Once you've done that, definitely make sure you do the homeworks on those pages. What pages were they? Right at the beginning. Even before this. Pages 24 to 27. So I'm just going to have a quick look now, because I've not really looked. End of 25, there's some homework, and the end of 27, there's some homework. So get those done, and we'll go through those next lesson. All right, well done.